So when I draw them, they would be parallel, right? But that doesn't trick your eye. To trick your eye, you need to break this rule completely. In fact, you need all of your parallel lines to intersect. Bless you. So do you see that these lines in reality are parallel? But on the picture, they intersect, right? Right here at a point. And if I were to take all these lines and extend them, they would also intersect at that point. Like all of these edges of the building all go to that point, don't they? So it's like all these lines that were parallel here, in this picture, they all intersect at a point. Now, for those of you who've done some drawing, know the name of that point?
I just have a question.
Mm-hmm.
Would it be the slope that's in common? Or would these have different slopes?
For each of these?
For parallel lines?
Back here, yes. Back here, when I was asking you what's the definition, this will be, we will say that they have the same slope, right? All I'm trying to illustrate here is that in general, okay, if you're talking to somebody, if you're sitting there on the Who Wants to Be a Millionaire, right, that show, I don't even know if it's still on TV, but someone asks you the question, are two parallel lines never intersect, true or false? It's a bad question, because this right here, they do, right? They do here, and they don't there. So this right here, does anyone know what that point's called when you're drawing things like this? No one's taken art in here?
I forgot, it's slipping my mind, it's early, but it's 1 point.
3 point?
No.
3 point perspective? Well, it's called perspective drawing, but the point at which all your parallel lines go together is called your vanishing point. And that's kind of where the road would vanish away off into the distance. So have I redeemed myself here? I'll just put this here just to, yeah, there you go. All right, so what is my point? My whole point of this drawing is just that what we study in this class is based upon what's called Euclidean geometry. And in Euclidean geometry, this is true. But when you go to a different geometry, and there are different geometries, like this one, which is called perspective geometry, then these rules no longer apply. And you have a whole new set of rules. So I guess I'm telling you, like the world you live in, right here, that we do in this class, and most math classes you'll ever take, is Euclidean world, and the rules here are fixed, but that's just a fishbowl. There are other worlds of geometry out there that we deal with in everyday life. So as a student of math, I actually had to take an entire sequence of courses called non-Euclidean geometry, where basically we studied a bunch of geometries that were not these, like the one you're used to. Okay, so two parallel lines never touch, right? The way we're going to define it, though, here, back in Euclidean, is we're going to say two parallel lines have the same slope. Must have the same slope. Right, so if you have if you're going to say that two lines are parallel, then their slopes must be the same. So in terms of writing that as an equation, what we're saying is that the slope, I'm going to write it this way. Let's say I have a slope of some line. I'm going to call it line 1. The slope of line 1 must be equal to the slope of line 2. If the two slopes are equal, then you can say they're parallel. Let me give you an example. Let's say I call this one L1, I call this L2. Two lines, right? These are two lines? Are they parallel? Yes, because their slopes are what? The same, 4 and 4, right? They have different y-intercepts, but they have the same slopes. So these would be parallel lines. All you have to do is look at that number, compare them. All right, so what about perpendicular then? Perpendicular means that we hit like this, right? Like at a T, perfect T, or 90 degrees if you're familiar with that. So if we hit at a T, what do you think the relationship is with the slopes?
They're inverse.
Yeah, so like they're inverse in some way. Let's say I have L1, and let's say the first line, I'm talking about perpendicular here. Let's say the first one is this. Do y'all have a guess as to what the slope would have to be of the line that would be perpendicular to this one? 1/4? Does it seem like taking the reciprocal of that might be, or do y'all think it's -4? Most people will say it's -4. Other people will say it's 1/4. No? I'll tell you. I mean, it's not 1/4. And it's not -4. It's -1/4. So what did I do? If this one is 4, then this one has to be what?
Negative.
That one flipped over, right? So this is really 4/1. Flipped over and changed the sign. Okay? That's how you know two lines are perpendicular. The slopes are flipped and change the signs. So the way we say that is negative reciprocals. You don't need to worry about that. Okay, that's what it is. Let me give you another example of perpendicular lines. Let's say I have a line and the slope is 2/3. Then another line, what would the slope of this line, this other line have to be for them to be perpendicular? What is it? -3/2x. And then this number doesn't matter. This number is just the up and down. So do y'all see the difference between parallel? Parallel, pretty easy. Same slopes, right? Perpendicular, you have to be able to flip one over and change the sign and to get the other one. So on your homework for this, let's go look at the homework because I think yeah, this is the homework. Let's take a look at this and we only have a few more minutes. All right, so the homework, write the slope-intercept form of each line, identify the slope and y-intercept. So this is what we started class with. Find the slope, put it in slope-intercept form. Okay, then, all right, this we didn't talk about. This we didn't talk about. But this is something, I wouldn't even test you on this, but you need to know it. If you see a line that's pitched like this, is the slope positive or negative? Positive. Here, 0. Here, negative. Okay, so if it's like from left to right, you always read it like a book. If you're going up, it's positive. Down, it's negative. Flat, it's 0. Okay, graph these lines. Would that be easy to graph? Relatively easy? Yes. Y-intercept is -5. Slope, negative. Ooh, what would you do with the negative here because it's out front? Is this down 3 or where does that negative go? Remember I told you it's your choice. You can put the negative on top or you can put it on the bottom. It's your one or the other and that'll give you your slope. This one right here, solve for y, graph it. So all that you should be able to do. That's going to suck with the fractions. That's horizontal. That's going to suck because of fractions. Okay, on these problems, notice the instructions say just to find the slope of the line. In class, I asked you to find the equation, right? So here, just the slope. You're just going to use the formula for m. For that, and that. And then I want you to see how these go. This has to do with perpendicular and parallel. I didn't really go through an example, but I want to see how you do with those, and then we'll start class next time with any questions you might have over those problems. And that'll be it. And then we'll start functions next time. Y'all have a good weekend. Is it ready? It's already, yeah, it's Wednesday. Y'all have a good weekend. Do your homework. Let's have a quiz on Monday, yeah? Yeah, let's graph a line. That's the way I felt Monday.
Yeah.
I just wanted to go curl up in a ball somewhere.